All right, let's begin a unit on the applications of trigonometric functions. We just completed a unit on solving trigonometric equations, and our first application of trig is the law of cosines. Let's first write the law of cosines. A squared equals b squared plus c squared minus 2bc times the cosine of a. So there's a lot of things to go through about this formula. First, this formula is given to you, so you do not need to memorize it. Second, we'll have to learn how to label a triangle to determine what information this is giving us. So let's draw any triangle. Let's call this A. Let's call this B. Let's call this C. Notice that the angles are capitalized. So since this is capital angle A, it creates side A, lowercase. Since this is angle B, capital, it creates side B, lowercase. Since this is angle C, capital, it creates side C, lowercase. So let's just see what this formula is giving us. It's saying that we're looking for a squared. But we're given everything else. So we're looking for an a squared, and we're given b, we're given c, and we're given angle a. So let's circle those. We're looking for this, we're given this, we're given this, and we're given this. So that's pretty easy to recognize if we were given a diagram, or even information that we could draw ourselves a diagram. This is what's called an included angle. It means there's two known sides surrounding a known angle. Okay, so let's work on an example and see how we would use the law of cosines to solve for a side. Let's draw ourselves a triangle and say that we have a 30-degree angle. This side is 2, this side is 5. Let me draw that angle on the inside. There we go. And we want to know this. So the law of cosine says the side that you're looking for, let's write the law of cosine first actually. A squared equals b squared plus c squared minus 2bc times the cosine of A. Notice the double C here. The C is for cosine and C for the side, so make sure you're writing both. Alright, so now the way the law of cosine is working is the side that you're looking for comes first. So in this case we would have x squared. We don't have any sides or angles labeled here. So if this were angle like D, E, F, I wouldn't be concerned with the letters here. I would be concerned with that we're looking for the side opposite the included angle. So x squared equals. And then you have to think to yourself, all right, x squared equals, what sides are there? Well, there's a 2 squared. There's a 5, plus 5 squared, minus BC, 2 times 5 times cosine of 30. Now, the rest is all calculator work. You can plug this into your calculator just the way it looks, but be careful, it's x squared equals, not x equals. So I'm just going to plug in exactly the way it looks. 2 squared plus 5 squared minus 2 times 5 times the cosine of 30. I'm going to make sure my calculator is in radian mode, degree mode. And we're just going to do 2 squared plus 5 squared minus 2 times 5 times 2 times the cosine of 30. Enter. So we get, well, something's wrong here. 2 times, I did 2 times 5 times 5 times the cosine of 30. Let me try that one more time. 2 squared plus 5 squared minus 2 times 2 times 5 times the cosine of 30. So we get 11.67. Don't forget, this is what x squared equals. So x squared equals 11.67. Therefore, x equals, and I'm leaving this decimal on my calculator for rounding purposes. So I'm just going to take the square root of the answer. So second square root, second answer. Not what I wrote down. I'm going to use the answer function with my rounding error. So if we're rounding to the nearest tenth, then we have x equals 3.4. So there we go. That's how you use the little cosines. Let's do one more example. Let's call this 120 degrees. Let's say that we have a side here which is 10 and a side here which is 11. So first of all, I know I can use the law of cosines here because I have an included angle. Since I have an included angle, I can find the opposite side using the law of cosines. So even if this were triangle x, y, z, just review how to label this. That means this is little y, that means this is little x, and that means this is little z. So I'm going to write the law of cosines using the variables that are given here. So y squared equals, then you have to think what other two sides are there. There's an x and a z. X squared plus z squared minus 2 times x times z times the cosine of the angle that's given, which is capital Y. Notice the symmetry of the law of cosines. Not that they're the same, but little y, capital Y. That's always going to be the case. Little a, capital A. That's what creates the included angle. So let's plug in our known information. Y squared equals 11 squared plus 10 squared minus 2 minus 2 times 11 times 10 times the cosine of 120. And we're going to plug it in just the way it looks. If you want to do this by hand, I wouldn't recommend it just because it's all one line in the calculator. Just remember your order of operations here and make sure you're doing -2 times 11 times 10 times cosine of 120. Then you're adding that to 11 squared and 10 squared. So just be wary of your order of operations here. So let's plug it into the calculator. We got 120, 10, and 11. So 10 squared plus 11 squared minus 2 times 10 times 11 times the cosine of 120. Enter. Don't forget, wait a minute, I got a double squared up here. Don't forget, this is what x squared equals. I just had a double squared in here, so let me delete it out and evaluate one more time. Delete, enter. All right, so we have x squared equals 331. Well, y squared in this case. So we'll take the square root of that, and that will be the length of our side. So second square root, second, enter, enter, and 18.19. Okay, so now this side is 18.19. Always go back and make sure your answer makes sense. In this case, 120 is going to be the largest angle because it's 180 degrees in a triangle. Therefore, 120 degrees will be the largest angle, which will yield the largest side. So make sure your picture makes sense after you plug it back in. And then what we're going to do tomorrow is we're going to manipulate the law of cosine to see how we can use it to find an angle measure.